Welcome back to Part B. We are picking up right where Part A ended. Let's continue. Question 8. Solve the simultaneous equations e to the power x plus e to the power y minus 8 equals 0 and 2e to the power x plus e to the power 2y minus 16 equals 0. The trick is to substitute. Let a equal e to the power x and b equal e to the power y. Then the equations become a plus b equals 8 and 2a plus b squared equals 16. Note that e to the power 2y is b squared. From the first, a equals 8 minus b. Substituting into the second gives 16 minus 2b plus b squared equals 16. This simplifies to b squared minus 2b equals 0, so b is 0 or 2. Since b must be positive, b is 2, and then a is 6. Finally, e to the power y equals 2 gives y equals natural log of 2, and e to the power x equals 6 gives x equals natural log of 6, option D. Question 9. The mean of 5 observations is 4.4 and the variance is 8.24. 3 of them are 1, 2, and 6. Find the other 2. Here is the idea. The mean fixes the total of all the values, and the variance fixes the total of their squares. 2 totals are enough to pin down the 2 missing numbers. The sum is 5 times 4.4, which is 22. So the other 2 must add to 22 minus 9, that is 13. For the squares, the total of the squares is 5 times, in brackets, 8.24 plus 4.4 squared, which is 138. The known squares 1, 4, and 36 add to 41, so the other 2 squares add to 97. From the sum 13 and the square sum 97, their product is 36, so they solve t squared minus 13t plus 36 equals 0. That gives 4 and 9. The other 2 observations are 4 and 9. Question 10. Given the vector BA equals 2, minus 3, and BC equals minus 3, 1, find AC. To go from A to C, imagine walking from A back to B, then from B onward to C. So AC equals AB plus BC. But AB is just the reverse of BA, so AC equals BC minus BA. That is minus 3 minus 2 in the first slot and 1 minus 3 in the second. This gives minus 5, 4. The answer is option A, minus 5, 4. Question 11. Write the equation of a line in symmetric form. A line in space is fixed by 2 things, one point that lies on it and a direction vector telling us which way it goes. Call the point x0, y0, z0, and the direction A, B, C. As you move along the line, each coordinate changes in step with its direction component, so the shifts are all in the same proportion. Setting those equal ratios gives the symmetric form. X minus x0 over A equals y minus y0 over B equals z minus z0 over C. If one denominator is 0, it simply means that coordinate stays constant along the line. That general form is the symmetric equation of the line. Question 12. A surveyor sees the top of a building at an angle of elevation of 19 degrees. Moving 120 meters nearer, the elevation becomes 47 degrees. Find the height of the building. Each viewing point makes a right triangle and both triangles share the same height. From the near point, the tangent of 47 degrees equals the height over the distance. From the far point, the tangent of 19 degrees equals the height over that distance plus 120. Writing each distance in terms of the height and subtracting removes the unknown distance, leaving the height times, in brackets, cotangent 19 minus cotangent 47 equal to 120. That bracket is about 1.97, so the height is 120 divided by 1.97. The building is about 60.9 meters tall. Question 13. Use the standard results to find the sum from r equals 36 to 48 of r minus 1 times 3 r minus 2. The trick with standard results is to expand the bracket into powers of r first. Multiplying out, r minus 1 times 3 r minus 2 becomes 3r squared minus 5r plus 2. Now we can use the known formulas for the sum of r squared and the sum of r. Because the sum starts at 36, we take the sum all the way to 48 and subtract the sum up to 35. That leaves exactly our 13 terms. Working the constant term as 13 twos as well, everything totals 66,638. The answer is 66,638. Question 14. The region between the curve y equals x squared minus 1 and the x-axis is rotated a full turn about the x-axis. Find the volume. When a curve spins about the x-axis, each thin slice becomes a disk whose radius is the height y. Adding up all the disk areas gives volume equals pi times the integral of y squared. The curve meets the x-axis where x squared minus 1 is 0. That is at minus 1 and 1, so those are our limits. Squaring gives x to the fourth minus 2x squared plus 1, and integrating from minus 1 to 1 gives 16/15. So the volume is 16 pi over 15. The answer is option B. Question 15. Given that tangent x equals minus 12 over 5, with x between 3 pi over 2 and 2 pi, find the exact values of cosine x and sine x. First, the interval. Between 3 pi over 2 and 2 pi is the fourth quadrant, where cosine is positive and sine is negative. That tells us the signs before we do any arithmetic. Tangent is opposite over adjacent, so with opposite 12 and adjacent 5, the hypotenuse is the square root of 5 squared plus 12 squared, which is 13. Cosine is adjacent over hypotenuse, and it is positive here, so cosine x is 5 over 13. Sine is opposite over hypotenuse, but negative in this quadrant, so sin x is minus 12 over 13. So cosine x is 5/13 and sine x is minus 12/13. That brings us to the end of Part B. The paper continues in Part C. Open Part C next and keep going. We pick up exactly where we left off. See you in Part C.